what's a strong acid and what's a weak acid. And it's important that you understand the difference, but I can't give you a number to tell you exactly when you switch from being a strong acid to a weak acid. But I can tell you this. A strong acid is like sulfuric acid. If you just take a water solution and you put sulfuric acid in it, almost all of the protons will dissociate. That's a strong acid. It has a strong tendency to dissociate. If you take beta-hydroxybutyric acid and put it into solution, it's got a weak tendency to dissociate. It is not a strong acid. If you throw this in the solution, maybe 1 out of 1,000, 1 out of 100,000 molecules will dissociate. That's in a pure water solution. Now, we can make it all dissociate by combining enough hydroxide with this water to make this whole equation move in this direction. We just keep taking the protons away. This will keep dissociating, and we can make it all. We can turn all the beta-hydroxybutyric acid into beta-hydroxybutyrate. But what I'm talking about is when people describe a strong acid or a weak acid, they're just talking about taking that acid, putting it in solution, will it completely dissociate or not? Now, looking at it another way, a strong acid has no tendency to combine with protons. So later on, we're going to see strong acids have no tendency to be a buffer. The only ones you'll ever run into is sulfuric acid in the body. That's the one you make. But you might be interested in hydrochloric acid because you do make some chloride. But that's a strong acid. Hydrochloric acid, sulfuric acid. The first, maybe the first dissociation of phosphoric acid because it's got 3 protons to dissociate. But these compounds here are weak acids, and only a little bit of them dissociates. And furthermore, if you have them in solution, they're going to be able to act as buffers because when you add a hydroxide here, this compound, when you add if you add hydroxide to the solution, it will combine with protons, and this compound will dissociate to make more protons to keep the pH the same. If you add acid to the solution, this compound here will combine with the acid, and most of the acid will actually go into forming beta-hydroxybutyric acid, and the pH won't change so much. Weak acids can be buffers. Strong acids cannot be buffers. Okay, we went ahead with these things. We were out of order a little bit with this. We want to talk about, we're getting here to the Henderson-Hasselbalch equation, which you have to know quite well.